Okay, so we're going to give this a try this week over doing Google Docs. I'm going to kind of jump the gun just because I've got a class on Tuesday night that's going to be doing utility theory, so I don't think I want to go into utility theory quite yet, since I'm going to be doing it, and I don't know if I'll get another video done before then. So let's just go right where you guys are, and we're going to start the discussion with something pretty simple. We're going to do theory of the firm. So theory of the firm is really our discussion about how the supply curve, why the supply curve looks the way it does. Why is it upward sloping? We're going to look at all the math involved in that decision and what's happening there. The other thing about theory of the firm is just a little bit of background about businesses. So in your economics class, we're going to assume that all businesses are profit maximizing businesses. That means the goal of the business is to make as much money as possible. We know this isn't true in the real world, right? So I bet you guys can think of lots of examples of businesses that their goal isn't to make money, right? So I'm thinking about small mom and pop businesses where their goal might be to make money, but not as much money as possible. And so think about, a business on Main Street like an upholstery shop. They might have the goal of supporting and sustaining a quality of life, but not necessarily maximizing profitability. The other example clearly is nonprofit businesses. Their goal isn't to make as much money as possible either. So just in the back of your mind, always remember every business's goal, at least in the economic model we're presenting in this class, is to make as much money as possible. In other classes later on, if you take advanced classes, probably not in micro or macro theory, but more topic specifics courses, you could deal with the economics of nonprofit businesses. We're looking at how the model's altered to represent businesses that aren't solely maximizing profits but are looking for something else. So with that aside, there's a couple disparate things I want to kind of join together. So one is to talk about this concept of economic rent. So we've got two types of things we want to talk about, which is economic profit. And anytime I use profit, you're going to tend to see me use the pi symbol, and accounting profit. And these aren't difficult concepts to really understand, right? Economic profit, well, let's start with accounting profit. Accounting profit consists of a couple of things. We need to know total revenues, and we need to know total costs. And I want to break this down a little bit further. Total revenues is just going to be the price of a good times its quantity. Now, something you guys might not be getting from the book or from just doing the problem sets is that in the supply and demand model we're presenting, it's a very simplified, old-fashioned model. In fact, the model has been evolving, but it's really stayed stagnant and was developed over 100 years ago. We live in a world where things are different than the economic model. In the economic model you guys are learning, it's the most basic form, the most generalizable form. The idea is that there's, something you guys might not have got. It's the law of one price. So if we're dealing with goods that are perfectly homogeneous, which means they're equal in quality, they're equal in looks, you can't really, the way I like to describe homogeneous or homogeneous goods is to say that homogeneous goods are goods where you don't ask where they came from, right? You perceive all of the goods the same. So if you go to Apple store, to the supermarket and you look at apples, do you pick up an individual apple in all honesty for most people and say, where did that apple come from? Now, in the modern world, people do, but 100 years ago, no one asked that question. The only thing that determined whether you wanted that apple was the price of the apple. And so if we assume all the apples are the same, there's no reason that some apples would sell for more than others. And so the law of one price says that if you're selling a perfectly competitive good, everything sells for a single price, so your revenue is just the price of the item times the quantity. Your costs in the accounting terms are composed of what economists like to call explicit costs. So this is the cost for our factors of production, which would be land, labor, capital, and then we could throw in, technology and risk. Okay? So all we need to know is the cost of our land, cost of our labor, cost of our capital. So if we're looking at a very simple company like an Oreo cookie company, and we say, look, Oreo cookie is composed of 3 ingredients, chocolatey wafers, creamy vanilla filling, and goodness and love. And those three ingredients cost, $5, for example. And then the labor cost is another $1 for a batch, and that's about it, right? So $6 per, 100 boxes. So it's very much tied to explicit costs. So it's probably best to illustrate with an example. An example I always like to use is kind of a personal one. I have a friend who quit a job, and he had a job that was paying to make it round numbers, $100,000 a year. But my friend really hated this job. He was an engineer at the time, I think, for Boeing, and it just wasn't what he wanted to do. He didn't have a lot of time at home. He didn't have a lot of time to see his kids. He felt stressed when he went to work, but he was making good money. And so my friend decided to go out and he started a small business. Now, this small business was a party supply company in Hesperia, California, which, if you don't know where that is, it's kind of the middle of nowhere in Southern California in the high desert. Not a lot around, but it is what it is. And with this business, in his first year, so first off, he quit this job. And then in his first year, total revenue was equal to $175,000. So pretty good, right? He made some good money. His total costs, right? Total explicit costs from land, labor, capital, technology, risk was $100,000. Not too bad either. So the question then is, what's his profit? And we have two types of profit that are operating here. We've got the accounting profit, and accounting profit is equal to total revenue minus total explicit costs, right? Total explicit costs here. And so for my friend, his accounting profit then ends up being equal to $75,000. Not too shabby. But I want you guys to think, did my friend really make money starting this business? In total, would you have advised him, just on a money sense, should he have started this business? And I think for most of you the answer is no, because you say, look, he used to make $100,000, now he makes $75,000. So economic profit then is going to be equal to accounting profit minus the opportunity cost of land, labor, and capital. So the idea for my friend is his accounting profit is $75, but he has to subtract out the opportunity cost of his labor, which is he quit his job to start this small business, so he has to subtract another $100,000. And he ends up with an economic profit of negative $25,000. So not too good. Okay. So first off, I want to throw out the caveat. When we're doing theory of the firm, we're always using economic profit, but very quickly we slip into this mindset, at least in the problem sets and in the textbook and in intro class anyway, forgetting that it's economic profit. We almost always talk about, we almost are always talking about accounting profit issues, but what we really mean is economic profit. And textbooks do a horrible job of really representing this idea. So the idea of economic profit then is, factoring in the implicit costs and the explicit costs of doing some activity, of creating a business or doing something. So not too difficult, so we can go on next topic. So then we have the idea from there of economic rents, and the economic rents or economic profits are people who make above average rates of return. So let's say that a football player. What's the opportunity cost of being a professional football player? Someone with a nice big juicy, $4 or $5 million contract. Well, the opportunity cost of doing anything is what you could have done otherwise. So what could the football player be if they weren't going to be a football player? And if we look at the data for the most part, it looks like a lot of football players, they get college degrees so they could become professionals, but let's just say they could go on and they could get a job as an insurance salesperson making $125,000, $150,000 a year, and that's on the high side, but they were a local football star, people want to do business with them, you could see it happening. So then the economic profit or the economic rents are the money they are getting paid above what they could have earned elsewhere in the marketplace. I bet if you guys ask yourself this question, you'll find out that all of you have, if you have any work experience, there's probably one or two jobs where you were paid more than your boss would have had to pay you to show up to do the job, right? And if that's the case, you earned economic rents or economic profits, depends on your textbook. So up next, we want to move on and we want to talk about how firms are going to calculate those revenues and costs in the first place and how they're going to look graphically. So it's not actually that difficult of a project. So we want to start with the idea of producing, let's create a lemonade stand. And our product or our market is to sell lemonade. So first, I always like to start with the perspective of, what do you need to make lemonade? Or what's going to cost you things? What do you have to buy? And this is going to be a breakdown of all of our factors of production. So simplistically, we need lemons. We're going to need sugar. Need some water. Cups. We'll need a stand, a place to sell it, and space. And workers, normally just yourself if you're a small business person. Okay. So we could take this lemonade stand, a hypothetical lemonade stand, and we could observe it over a period of time. And I'm not going to ask you to do this, but I want you to imagine just hypothetically, if you had a bunch of data from this lemonade stand, and you had data such as 10 lemons, 2 cups of sugar, 2 gallons of water, would create, I don't know, 32 cups with 1 stand and 1 worker. And then you had some more data. And the next data was, look, 20 lemons, 4 cups of sugar, 4 gallons of water. We get 64 cups. Get 1 stand, 1 worker still. And we could keep going up the line until we're at the point where we have 400 lemons. And I'm just making these numbers up, so they might or might not scale. 400 lemons, 80 cups of sugar, and we need to think 80 gallons of water, and 320 cups. Still 1 stand, probably in a given period of time though, not doing that with 1 worker. So let's say now we need 2 workers. And so let's say you have all of this data about how productive your workers are. And you guys can already begin to see, hopefully, that there's a progression here. We can produce something called a production function. And the production function just tells us the output of lemonade is equal to some function of the amount of land, labor, and capital, and technology. In this case, our production function would be that there's some function with lemons, sugar, water, and cups, and workers. And space, which is our land. And I'm not going to do it here, but imagine if we put all of this data in. Do you think we could come up with some mathematical relationship where we could say, this is the equation? And let's see whether I could come up with something. So output of lemonade is going to be equal to, let's say, let's say, equal to lemons divided by, or multiplied by, so 2 times the number of lemons equals sugar, or no, plus sugar, I don't know. Too hard to make this up on the fly, but you can see what we're doing here. Plus water, plus cups. And so the goal is to kind of create this function that says how much lemonade we're going to end up. And so all we'd have to do is say, if we want this many cups, then we plug the number of cups in and we multiply times x, right? So you can say, maybe insert an x here. So x, 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 x. And this would be multiplied by, what do we have? 16, right? Plus our land and labor, those are constants. Okay, so we just hold those constant, no terms on there. And so we'd say, okay, if we want x cups of lemonade, then we can kind of insert in this and we say, okay, we want 32 cups of lemonade, 2 times 32, or whatever it be, right? Have to make that up. So this is what the production function does. It tells us for a given amount of lemons, right, we can maximize and then create a certain amount of lemonade, right? So the goal really is we take inputs, we connect them through to our production function, and we get some output. And the goal, a lot of times, is to efficiently use our inputs. So we want to produce the most output with the minimum inputs. Okay? So now that we know about our production function, let's create a very simple production function and say, look, production function involves an output, y, and one input, workers, me. Now let's imagine that my sole job, and this is too simple, but my sole job is to walk around this table, right? So I'm a worker, I walk around the table and we time myself for 1 minute and we say, how long does it take one worker to produce how many laps? And so we say, okay, in a minute, this fat guy named Joel can do an output of 6 laps. Okay. Then we hire another worker. So imagine there's 2 of me and we're both walking in a circle. And let's assume we're walking at the same pace. So we say, look, with 2 workers, we can get 12 laps. Then we add a third. And so, pretty easy, 3, 18, cool. Now what happens if we end up with 20 workers trying to circle this table? Do you think people will start bumping into each other and start getting slower and not as productive? Eventually, as we add more workers, the productivity of production is going to get lower and lower and lower. And so we say, look, with 20 workers, maybe in a minute, they can only do 60 laps, 3 laps per person. Not very productive compared, that's 50% of the production before. Now that's a stupid example. Let's imagine instead that this is my grill, this whole space, and I'm a worker and I'm making burgers. And so I put burger patties down, lay them out, boom, 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 boom. And then I take my spatula and I start working. And what we're measuring is, for each worker over a given period of time, how many burgers can they make? And so we say, look, in 1 hour, Joel, you're pretty fast, you can make 150 burgers. Then we add another person. Well, there's enough room for 2 of us. Pretty good, we're going good. Then we add a third worker. Well, that's okay. That third worker can lay out the burgers. We can flip and then they can collect them. We add a 4th worker to the same grill space. We add a 5th worker. Eventually what's going to happen is too many workers, too many cooks in the kitchen, not enough gets cooked. So if we want to graph this, then what we're really creating here is a production function. And we're graphing the output relative to the number of workers. And we can see that the graph of these production functions tends to look something like this, if we smooth it out. And eventually this graph starts going down. Because eventually you add so many people to the grill, so many people walking around the table that you can't do as much of the work as you did before. And in a worst case scenario, you get to the point where you have so many people working that you lose productivity and you can't do anything, right? You might go negative, which is probably never going to happen in the real world, hopefully. No boss would do that. So then we can ask the question, so what's the marginal productivity of labor, right? And marginal productivity of labor is just MPL. And I'll always abbreviate that MPL. But MPL is just going to be, we're going to say we add 1 more worker, how much more production do we get? So here we add 1 more worker and we get 6 more units. Pretty easy to calculate. But the general formula for MPL isn't that bad. It's the change in production from 2 points divided by the change in the number of workers. Why, or whatever input is. And this is the simplest version with 1 input into our labor market. So what are we doing? We're saying, look, the change from here to here, right? So we can go, we want to go from here to here. And so what we can say is the equivalent of going from 2 to 1, or 1 to 2, it doesn't make a difference. Let's do it that way, since I did it that way verbally, is equal to 6 to 12. Which is equal to -6 over -1, which is equal to 6. So the marginal productivity of labor of going from the first to the second worker is 6 units of production. But let's say we have this big gap from the 3rd worker to the 20th worker. Well, let's just do this really quick. So if we're going from the 2nd to the 3rd, we also know it's 6. But what about from the 3rd to the 20th? We can't simply say it's just 18 minus 60, right? Because we've got a big gap here. So we can do this and we say, okay, it's going from 3 to 20 and from 18 to 60. So that's -17 over -42 equals, so 17, 34, 2.5 approximately. Not really, but anyway, it's 17 over 42, so 34, 8 over 42, more like 2.25 estimate, right? You guys can solve it on your own with a calculator. And so we can see that productivity fell from 6 to 2.25 by adding people in. We ended up on that downward slope, right? So what I've graphed right here is the total production curve. So total production says, look, for one worker, we get 6. For 2 workers, we get 12. For 3 workers, we get 18. For 20 workers, we get 60. If we want to graph the marginal production curve, then marginal production is going to be 1 and 6, but it's not actually 1. What we're really calculating is the difference between 1 and 0 and 1, or 1 and 2. So from 0 to 1, it's 6. From 1 to 2, it's 6. From 2 to 3, it's 6. And by the time we hit somewhere in the middle down here, we're at 2.25. And so this marginal production curve looks something like this. What we know is that, and I drew this a little sloppy, but what we know is that marginal production is going to be equal to 0 okay? So marginal production, marginal productivity of labor or capital or anything else is equal to 0 when total production hits its peak or hits its maximum. Very simple claim, right? So we want to maximize total production, then we need marginal productivity to equal 0. The argument here is if marginal productivity is above the 0 line, if it's positive, then the total production has to be going up no matter how small it is. If it's negative, total production has to be going down, right? And if we're at 0, total production is neither going up or down. Okay? So that's what's happening. And we can do this for labor, we can do this for capital. In this intro class, we're only ever going to do it for one good. Keep things simple. Maybe in the problem sets it does 2 goods. On the exams, it'll normally only be 1 good as well. So this is your marginal productivity. Not too difficult. So now, we have our inputs, we put them through production function, we end up with some output, and the goal is to, at this point, the goal is to maximize output, but that's not the goal of company. The goal of company is to maximize profit. So now, what we want to go towards is, we've got this, and we've got different output scenarios. So we've got output 1, output 2, output 3, output 4. And so we know, and we can feed these through all different terms of ways of configuring our production. So for many companies, the more inputs you add, the more easy it is to substitute out things. So we have a lemonade stand, we're using sugar, maybe we get big enough, we say, look, corn syrup's cheaper, we could substitute corn syrup for sugar, which is going to be more effective in our business model. Maybe we have a choice, we can buy a mixing machine or buy automatic pressers for lemons and get rid of some workers, and so we can favor technology and capital goods over labor. So we have lots of production functions, and we have lots of outputs that come from those production functions. Now the goal is to really cost all of these outputs. So now we need to know something about the production costs. And by the way, I'm just hitting the high points. I'm not really going to go through a lot of details because there's other videos out there that kind of go through that. What I want to do is just hit some of the high points for you guys. So, when we look at the cost of production, we need to take into account that there's two types of cost. We have fixed cost, and we have variable costs. The way to think about this